Yeah, so where do we start with this? As usual, I'm using processing for this. And I explain this every stream, but processing, if you're not familiar, it's a Java-based framework or tool for quickly getting graphics and on screen and handling input and audio and stuff like that. So it's designed for like quick prototyping and for sort of artistic, visual, graphical kind of projects. Mostly like small, like fairly self-contained projects. So it's pretty good for something like this, which we're going to try and start and complete just in a couple of hours here. So in processing, the first thing you need to do is define your setup and draw functions, where setup is called once at the start of the program and draw is called once per frame. So this is actually where your update kind of logic goes as well as your drawing logic. So the name's a bit confusing, but this basically just gets called once per frame. And this gets called once at the beginning. First thing you always want to do is to create a window of a certain size. I guess we're free to make this any kind of size I want, so let's just play around until we get something that looks good. So there's a third argument here which just specifies a kind of rendering mode to use. P3D, even though we're rendering 2D stuff, this gets the graphics card involved and means that we can render stuff nice and quickly. So if I run this, we'll see our window pop up. I'm going to make this a bit wider. It'd be nice to be able to see maybe some more of the terrain here. Let's also give this a different background color. RGB 000, let's just fill it with black for now, like our traditional old school arcade version. Cool. So yeah, let's get out the whiteboard and think about how we're going to break this program down. So we have our screen, and there are two main components, right? We have the terrain, which I suppose also has these like landing pads on it. Kind of lost control of my stylus there, that got a bit funky. And then we have our actual landing craft itself. Where should we start? Should we start with rendering a terrain? That feels like a natural starting point for this. The way I think I'm going to do this is just to maybe break this down into kind of line segments, right? So if we zoom into this part here, maybe, it's like something a bit like this, which means all I kind of need to store for each of these points is the kind of height, basically. So if this is 0, and then this is like our terrain, it's just going to be a list of height values, and then we're going to draw lines linked together to actually render that terrain out for us. We'll probably have to do some kind of special case for the platforms. We could maybe always consider, like right here, if these points have the same height, then we could automatically make that a platform. That's one way to do it. Or we could kind of think about placing the platforms down as their own object. I'm not sure which way we'll go, so I'm going to start with just getting the terrain rendered out in some form, and then we'll figure out the landing stuff later. So since this really is just a set of height values, I can literally just use an array of floats for this, I think. You can just call this terrain. We probably also want to define like the resolution for this. Maybe not, right? Maybe we can just add a load of points into this array and it can figure out, oh, if you put 10 points in there, it means that we're just going to draw like 10 segments across the screen. Maybe we can do that. The other question is, do we want to have the camera kind of scrolling around? Maybe for a first pass we won't do that. I I can't remember if the way the original worked was that it was just like one screen, or whether there was actually scrolling and stuff. Let's make this a one-screen game for now. We can always tweak that down the line if we feel like it. So let's manually put some stuff in this terrain for now. Could maybe do something fancy with like auto-generating this. That could be cool. But for now, I'm just going to manually put a list in here. Another question is how we specify this height. Should this be 0 and this be 1 at the top of the screen? Is that a sensible way to do that? Or do we actually think in terms of pixels? Yeah, let's go with pixels. I also feel like I should call this terrain heights just to be a bit more explicit. This is probably going to look terrible. I've just thrown some random numbers in there, but we shall see. With the background, let's think about drawing the terrain. I like to use this style of comment for like section headings. So then I can have like subheadings underneath here. So I could just use a for each loop over this array, but I think I want to keep track of the index because that will allow me to map it to its its x coordinate and all of that kind of thing. Another thing in any language I always forget is its size or count or length for like the length of this thing. I believe it's just length like that. We're kind of going to need an x and y from this, right? So let's figure out how this will work. So we've specified a height, which is kind of coming up from the bottom, right? So let's say if this one is height like 200. But actually in processing, we have to draw from the top left, where this is y equals 0, and this is y going up here. So this actually becomes height minus 200 if we're kind of trying to work it out from the top left corner. And then the x, all we kind of have to do is divide the total width of the screen by the number of points. So this is a situation where it's very common to get like an off by 1 error or something. So let's just do a little quick worked example here. So we have 1, 2, 3, 4, 5 points, which only defines 5 minus 1 or 4 like actual segments here, right? Yeah, so the x coordinate is not, this is not width over 5, right? This is width over 4. This is 2 times the width over 4, this is 3 times the width over 4, and this is the full width. So our x is going to be I multiplied by width, so that's the width of the whole screen, divided by I could work out this once, so the width divided by that length minus 1. So this is simply I times x step. And the y is just going to be as in height of the whole window, minus, cool. So ultimately we want to render this in line segments. For now I think I'll just do little dot here to make sure it's working. Okay, I don't know if you can super clearly see this, but we have 1, 2, 3, 4, 5, 6, 7 dots displayed here. We have our 7 height values. Okay, that seems to be working as we would like it. Let's now think about lining these things up. So yeah, so in fact this isn't quite going to work for us now. So it relates to this thing, right, where we have 5 points but actually only 4 line segments. So if we want to draw like this line here, then in fact we need to consider like 0.0 and 0.1, or 0.0 and 0.1 here. So there's a couple of ways to do this. So I think processing will let us just draw a list of vertices as like a set of lines. Later when we come to do like some physics and stuff involving these, we may need to have a nicer way to like consider each line segment and sort of iterate over those, but for now we probably can just say something like begin shape. Hopefully vertex will do what we want. Okay, so this is a handy, I think I've got the syntax right here. I'll check the reference if this looks weird, but basically processing will allow us to say, hey, I'm going to start drawing a shape, and then I'm going to give you a list of vertices, and then I'm going to finish, and I'm going to tell you how I want those all rendered. So if you do lines, it would just do line segments. It's also possible to have it like close it off to make it like a filled polygon or something like that. But for us, okay, yeah, you can see it's done something weird. Let me check the exact syntax for this. Okay, I should have used it as a parameter to the first one, it looks like. In fact, no, I probably want... Okay, so what this is doing, it looks like, this is kind of small, you probably can't see this, is if you just say lines, then it will want a separate list of line segments. So in this case, we would need to say 0.0, 0.1, and then 0.1, 0.2, but actually we want them all kind of joined up like this. So the way to do that is just to say no fill, and then we'll still have the lines drawn. Maybe we'd have to set a stroke color or something, but I think that would do what we want. So what we probably do want to set is, in classic arcade style, we'll just draw this in white. Stroke weight, let's make this a little bit chunky. Okay. Seems to be working there. Should we throw a few more terrain points? Let's make this a bit more extreme, I think. Cool. Kind of weirds me out that those points were perfectly in line. Yeah, okay, it is drawing the correct set of things, it seems. So we should probably designate, I suppose just for our testing purposes, let's just make this one here a platform. All we need to do there is just make sure that 2 adjacent points have the same height. Cool. So we've got some basic terrain. We could figure out more complex ways to generate this kind of thing in the future. But for now, I think this will let us test things out. In fact, let's have a platform like at the beginning or on the left and one on the right as well, so we can have more of a target to kind of fly around with. One issue is that the more points I add, the shorter these platforms get. That's probably okay. It'll just kind of dictate the size of the ship a little bit, I suppose. I mean, we could be kind to ourselves and give ourselves bigger platforms. Okay, so we have our terrain. Now it's kind of time to start thinking a little bit about our actual lander craft itself. I do, in fact, have a bit of artwork lined up for this, which I think might be kind of fun. So in Steamhounds, we have this engineer character, and you may have seen in some of the GIFs for this character that it's got this levitation ability. And to me, this really kind of looks like one of these lander crafts, so I may just actually use this sprite as our lander. So I'll just need to chop it out here. Snap to grid would help. Okay, throw this into a new image. Let's also put a grid on this one. I wish there was a faster way to do this. I'm sure there is, and I just don't know it. So what I kind of want to do is just have this like centered within each frame, and also maybe all the way down to the bottom here, so that it looks more like, you know, we're more able to easily position this so that he seems to be above the ground. Let me export this. So as usual in processing, we have a data folder. Throw this in here. So there was some code from a previous one of these challenges where we did like an animated sprite. And generally speaking, I'm trying to make all of these like from scratch every time. But since the animation is not really the focus of this project this week, I mean, if you want to learn how that's done, you can go back and check the VOD for the 2-button brawler project. But just because it looks cool, I feel like I'm going to allow myself to effectively like copy and paste the code from that. That would be kind of the only thing, and I'll quickly walk through how it works anyway. So add a new tab. We also have this animation class. So all this does is it specifies like a position in the sprite sheet for all of these things. So when you're doing sprite animation, you can't really see this grid. Let me make this a bit more garish. Yeah, when you're doing sprite animation, all you're doing is, you know, first showing this section of the image, and then this one, and then this one in a kind of flipbook style. So to kind of designate an animation, all I really need to do is say, hey, this is like 7 frames long, and it starts here, and each frame is like this kind of size, and that kind of specifies the animation. So that's all we have here. Also how long to display each frame for, and whether the thing should loop. And then in the sprite here, I feel like we don't need this. All we kind of want to be able to do is take a sprite and display it at a particular position. So I'm just thinking about the best way to display this, and although it's very... I actually maybe don't want this thing... I'm going to have to rotate this thing around, and I probably want him to rotate around his center, so I probably in fact don't want this stuff all like right on the ground. I actually more want it like center of mass, and then I'm kind of going to have to define his like size in some way or other. We will cross that bridge when we come to it. So inside the sprite class, we just have a list of animations sort of saved by name. We know which one we're on currently and how many seconds since we started the current animation, and that allows us to figure out which frame we should be displaying at any point in time. So if we're looping, we'll kind of go over the frames and then use this modulus thing to loop back around. Otherwise, we will sort of hit a limit and just halt on the last frame eventually. All this rotation stuff we can handle actually outside of this code, I believe. Yeah, this is the bit which actually chops the correct frame of the image out, so you tell it what the image is. Let me actually make a constructor for this. Kind of confusing a sprite class having a member variable called sprite. So we take the sprite sheet, we're going to draw this thing, sort of output this thing at the origin, and we're going to output it at its original size. So this is, yeah, the kind of output size on screen, and it's just going to be whatever the width and height of the frame is. And then this tells us the top left of the frame, and this tells us the sort of bottom right of the frame that we're drawing. So this kind of chops out the correct part of the image for us. And this tells us like where to draw it and how big, essentially. Yeah, so we should be able to... Let's make a little class for our ship here. It's going to need to contain a sprite. It's going to need a position as well. This thing's going to need to be able to draw itself. Probably also update itself, sort of anticipating here. So when this thing's updated, we kind of need to tell it the sprite, hey, some time has passed. So sort of update the animation. Then when we draw it, all we do is use these functions to kind of, these act as like a save and restore for the translation and transformation and, you know, positioning, scaling, rotation of stuff, so that we don't screw it up and apply it to other objects which we draw as well. So we move ourselves over according to our position, and then we just tell the sprite to draw itself. So what actually happens is the sprite effectively draws itself at 0, 0, and we do the translation outside of here. That's because it also allows us to, you know, like do rotations and other kind of things along with that. Let's put this at a sort of arbitrary position for now. Leave the lander. We'll also need to initialize its sprite. Should load an image of, if we call this ng-sprite.png. Okay. We also need to tell this sprite that it has an animation which it should know about. Right now we only have one, and it's this flying animation. So we need to put in the various information here. So it starts at 0, 0. It's the only animation in the sheet. Frame width and height I happen to know is 128 for this sprite sheet. Number of frames, we already looked, so that's 7. Frame duration seconds. So I believe these are at 20 FPS. We can always tweak that. It does loop. So we put an animation in there. Then we have this function called change animation, and all this does is it looks at the animation based on the name, and then it just resets the counter to 0. So this may actually do what we need. We'll check. There's maybe something I forgot to initialize, but make sure to call the lander update. So something else we need to do in order to keep the animation ticking along at the right speed is to know how many seconds have passed since the previous frame. So that allows the animation to progress the correct number of frames according to that. So we just use this handy function processing gives us, which tells us the number of milliseconds which have elapsed since the very start of the program. So the delta time, or the elapsed time for this frame in seconds, is whatever the current time is minus whatever the previous time was. that tells us how much time has elapsed, so we can throw that into here. But then we also now need to update this thing so that next time around it compares the next frame's time with whatever time this frame ran at. So that should do that for us. I mean, this is super common. Every project we've done has more or less involved this, so it's kind of memorized by now. But this is a super common pattern. There are other ways to try and regulate timing, but this is probably the simplest way. Okay, so we're getting no errors, but I bet we forgot to even draw our lander here. So we should see him in a random position, skewed off to a weird angle. Nice! Okay, and the animation appears to be working. This is kind of fun. So let's... looks kind of fast, but it will do for now. Let's get rid of that weird angle thing we threw in there for some reason. So we have a position. We probably also need to know what our rotation is. It's going to start off at 0. We can just rotate like that. Nice. So now I think it's about time to get some actual controls going into this guy. So I don't quite want to figure out collision with the terrain just now. That's something we'll do after the basic physics, I think. But what I would like to know is... we kind of need to know how big this character is in terms of like a collision box or circle or something like that. So... and I also want to make sure he really is kind of centered, so I'm going to add a guide here. We can kind of check. So I'm looking down the bottom, by the way, for the size of this box which I'm drawing. That's 37 pixels tall. Up top he's like less than that, so we should probably move him up slightly there. Then his height is, yeah, let's say like 35, that seems reasonable. So for now I'm going to think of him like a circle, which is maybe a bit odd, but it's kind of for debugging purposes, let's actually draw that circle. I think when you draw an ellipse, it takes like the full width and height, so that's actually radius times 2 in each axis, because it's not just an ellipse, it's a circle. Cool, okay, that seems to be a reasonable kind of collision area for this guy. Cool. Oh, you know what? No, okay, everything's in seconds. I thought this is wrong, right? This is the number of milliseconds since the last frame. There's 1,000 milliseconds in a second, so he's actually animating at 1,000 times the normal speed. There we go. That's a lot more cash. Yeah, that makes more sense. Since it was animating so fast, it was effectively just landing on random frames each time, I imagine. Or maybe getting into some kind of cycle. Cool. let's also think about positioning him. So I could figure this out mathematically. I could also just kind of take a screenshot and measure his starting position. Put him in the middle here, then we're looking at 180 by 500. Oh, of course, but I want to... It's a bit messy, but it will kind of do for now. Okay. So if we're going to be able to fly this guy around, we ultimately will need some kind of physics stuff going on. So as well as a position, let's give him a velocity. Which we will start at 0. So now we can do a bit more fancy stuff in the physics here. So I guess what we need is some gravity, right? So what that's going to do is it's going to increase the y component of the velocity. So again, because processing has y starting at 0 and kind of increasing down, we actually need to add like a positive y if we want to create a force which pulls him downwards. So the way we can do this is something just like, you just add, well, let me just put arguments like that. Okay, here we'll let's add a parameter up here for like gravity strength. Let's add that on, but we should also multiply it by the amount of time which has elapsed, right? Because if 10 seconds have elapsed since the last frame, then gravity will have had more effect on us over 10 seconds than if it's like, you know, we're running at 1,000 frames per second and it's like 1 millisecond has passed. So we kind of need to modulate all of our physicsy stuff according to this delta time. Yeah. So that will affect our velocity. We need to then actually update our position according to our velocity. So if we're at this position here and our velocity is like this, then based on how much time's passed since the last frame, you know, we're going to appear like here or here or here, or, you know, somewhere along this line. So what we do is we just say so we want to take the velocity and multiply it by the amount of time that's elapsed. So if the velocity is in like pixels per second, then if a second has passed, then we'll just add the velocity on as is. If it's a tenth of a second, then we'll add a tenth of that value on, whatever it may be. But this should basically do what we need. Yeah, somehow the like error detection is kind of going a bit crazy because, yeah, my syntax was, I had the correct number of brackets there, I was pretty sure. Okay. So gravity is having its effect on us. We're speeding up, we're slowly falling off the world. Ignore the fact that we just fell through solid rock. what we really need is the ability to move this thing around, right? So to kind of thrust this thing forwards. So the way that this works in Lander essentially is you always thrust in the way you're facing, right? You don't have like strafing kind of controls. You don't have like a stick where you can move in any old direction. It's like a turn, like tank style, right? So you like turn and you thrust in whatever direction you're facing. So if I like rotated the guy over so that he's trying to draw the guy in his jets there, he's facing, you know, he's rotated that way, then he'd then thrust in that direction. So it's as simple as saying, just going to thrust. Let's add another tunable parameter up here for strength of our thrusting. It should probably be greater than the strength of gravity, or we would just end up hovering still. So I'm going to say arbitrarily for now, let's make it 3 times the strength of gravity. Okay, here's where things get interesting. So right now I can just say, do something similar to this, right, and just have us thrust straight up, but in fact we should be accounting for the angle we're facing. Thrust strength. This would actually thrust us down, so it's kind of like a minus thrust strength. We'll be pointing straight up. Actually, probably the nicer way to do this is to not make this a public method. So the reason I made this public was because I imagined that sometimes it's convenient to handle the like keyboard input out at this top level and then just pass it through. But we're not really responding to like button presses as such. It's more like, is a button being held right now? Which we can quite conveniently check, I hope, inside the update function here. What I really want like is like an is key down. If any key is pressed. It's weird. Normally there's a way to get like a boolean for any given key to see whether it's down. That's maybe something I need to keep track of myself. In which case, I'm sure I'm missing something, but I'm just gonna do this here because it's going to be the quickest way through this, even though it's probably kind of inefficient. So I think what I'm going to do is for non-ASCII keys use key code, so I think that's what I need for the arrows. Key code is... Come on, what type is this? Okay, an int. So processing will automatically call these key pressed things for us. Do we have a key released? Yep. So I'm just somewhat suspicious here that useful first to check if the key is coded. Yeah, okay. So it's possible that I'll get like a key, like a letter key, and then that variable may give me the wrong impression. So what I should actually do is only do this if it's one of these coded keys, which the arrow keys are. Cool. And then I think what I'll do is, so if hell keys contains, I'm going to say up. I could use spacebar, but I think left, right, and up are the most common controls for this, I think. So I know this is wrong, but it will work for now since this won't account for which angle we're facing basically, and I will do that. Add that to this in a minute. Right now it should just thrust straight up. Yeah, there we go. Okay, I feel like that's kind of super slow. Both in terms of gravity and my thrust. It's kind of trying to get the feel, the lander feel right at the moment. Okay, we're kind of getting there. Yeah, this is in the reasonable range. That kind of should be tweakable. Now let's think about having this thing rotate. So visually making it rotate is easy enough. I feel like I should put the sort of voluntary stuff above the involuntary stuff, maybe. Gravity just kind of happens, so does just the position changing. Thrust and rotation are not quite like that, so if contains right, similar with left. Should probably have a rotation speed in here. Yeah, no frame of reference for what this should be, so we're just going to play around with some values here. I'm going to say rotation, I'm going to add to it the rotation speed, but again multiplied by the elapsed time. Kind of need to do this absolutely everywhere, to be honest. So I should probably mention that when thinking about angles in mathematical context, we might often think of like angle of 0 as being kind of straight up, and angle increasing like this, when actually it's more like in terms of maths and like graphics and rendering, like a 0 degrees kind of points here, and then it increases in this direction. It's kind of aligned with like the x-axis here. So if we're holding the right arrow, the angle's actually, you know, this angle here is actually getting smaller. So the upshot of that is these are the wrong way around. I think. Let me gone into all of that. Beginning to doubt myself. Yeah, I'm wrong. Okay, yeah, so the thing is I'm still just thrusting straight up. All I need now is to take the angle into account when I thrust. Am I going to come back down? Is there something weird there with the key getting stuck on? That seems okay. Okay, let's do a bit of lovely trigonometry to figure this stuff out. So we have our guy, he's at a certain angle. It's going to draw him as a blob this time. Let's say he's now at more like this kind of angle. Then yeah, I guess given how processing doing this, we're actually can't draw a straight line. Let's actually draw a straight line. Okay, that's the straight up. Like this is our angle here. So we need to figure out. Essentially, we want this vector, right? Because that will give us which direction to thrust in, and to derive this vector, we kind of know that we have this little right angle triangle here, where this is sort of the x and this is the y. So we can use a bit of trigonometry, a bit of SOHCAHTOA stuff. So the sine is the opposite over the hypotenuse. So sine of our angle is going to equal the x component of our vector, you know, this component here, and then the cosine is going to equal the y component. We would multiply by the hypotenuse, but we actually want like a unit vector. You know, we can just scale this thing up by the thrust speed. So it's equal to. I bet there's a helper function like from angle. Yeah. Okay, so we don't even need to worry about the trigonometry. Like maybe I should include it for like educational value, but screw it. If it's there, let's just use it. Yeah, so then what we want to add is multiply it by, again, like the thrust strength times the delta seconds. We can just add that onto the velocity like this. No, we're probably off by like 90 degrees or like flipped in the y-axis or something here, so we will figure that out. Yeah, look. This is where the like 0 degrees is like to the right thing sort of comes in. So we kind of need to figure out Actually, let me do a bit of rotation and make sure that's acting correctly. Okay, so we're just off by 90 degrees, right? Yes. So all I kind of need to do is add 90 degrees, or I suppose in this case it's pi by 2 radians. Oh, that's exactly the opposite direction. Yeah, okay, let's actually figure this out rather than throwing random numbers in there until it works. So with an angle of 0, he's facing like this, like as we kind of expect. But the vector this gives us is actually pointing in this direction. So what we need to do is we need to rotate this kind of to align with the way he's like visually facing, which is just 90 degrees. And it's sort of in that direction, yeah. Okay, this was very landery already, if I'm honest. That's where you have trouble trying to land on the correct place. Ah! Yeah, so in terms of extra stuff here, we need to add a bit more logic, right? We want to have a nice actual like takeoff happening, and we want to be able to actually have landing happen as well. So in terms of takeoff, I think we can have like a state machine of some kind around this. So how are we going to do that? So think about the states this thing can be in, right? I think that maybe only 2, or well, potentially 3. So we have kind of a like an on ground. Let's call it grounded. And then we have flying. And then obviously when we press like the up key, right? We want to go to flying, or yeah. And then we want to go back to grounded. And this is a bit more subtle, right? Like this is how landing happens. There's going to be a few criteria which determine if we're going to land. So it's going to have to be something like the angle is like almost 0. We want to be more or less like level. So let's say level. We also want to be like moving slowly downwards. And also we actually want to be like touching the ground, right? Like touching a landing pad or a level piece of ground. Just call it that pad. Okay, and the third state here is dead, like exploded, right? And that happens when you touch the ground in any other case than this, right? Like if you hit some unlevel ground, or you hit the ground upside down, or you're coming down too fast, or pretty much any other situation where you're in contact with the ground, you're toast. And then maybe there's like a reset ultimately, which kind of takes you back, but that's more of like a restart the game kind of thing. So obviously you're dead if you crash. We can kind of reset you. Okay, so let's start actually mapping out these states in code. So again, if you watch the 2-button brawler stream, it's going to be very similar. We're going to make a kind of simple state machine for this. And when you're just dealing with a few states in like a self-contained thing like this, I normally just reach for like an enum to do something like this. Okay, so let's add some states, I think, into this. So we had grounded, we had flying, we had dead. So I forget processing does some weird stuff with how these classes are actually defined, so I actually probably need to create a separate enum for this, or a separate tab. But now I can say it's definitely behind me on the like completion here. Okay, I think what was happening is I had some like a Dropbox style thing in the background syncing stuff, and it was kind of getting in the way. Okay, this looks good now. So now we kind of need to do different stuff depending on what the state is, right? Like all of this really only applies if we're flying. So let's actually put this inside a separate method. And we can kind of have a switch statement here based on our state. So if we're flying, then we want to call our fly method and let it know how many seconds have elapsed since the last frame. If we're grounded, then we kind of don't want to do anything. If we're dead, we also don't really need to do anything. Kind of what we actually need to do here. We really are going to do nothing if we are dead. Okay. This is not defined yet, so now we want to transition into our flying state. So right now we only have one animation, but this is actually the point probably when we would start flying. So let's put this here. Obviously the state is now going to become yeah, so the auto completion on this ID is not super great. The state's going to become flying, and let's just give ourselves a bit of just a little bit of upward velocity maybe, so that we don't immediately hit the ground again. In fact, that should be yeah, that should be negative. Okay. So this should mean that at the beginning we're in this grounded state, right? Physics and stuff is not affecting us. If I can press left, right, down, nothing does anything. If I hit up, then I found myself flying. Okay. I can fly myself around. This actually already feels very lander-like, if I'm honest. I don't know if that would have been a successful landing or a crash, but that is the idea. Okay. So I feel like now we need to handle some collision stuff, right? So let's put another function in here to handle that. You know what, I think I may leave the actual collision code till after our little half-time break here, and I'll do something a bit lighter for now, which is just the what do you call it, the transition between different animations and stuff like that. So let's load in a couple more animations into this sprite sheet. I feel like I'll want maybe 2 more. I want one for him taking off. Well, I suppose one for him kind of just sat on the ground, one for him taking off, and then one for him dying as well. So in fact, I'm going to end up with 4. We've got all these cool animations, may as well use them. And I'm kind of lay them out on the sprite sheet more or less in order of their like sequence. So I'm going to move this down by, I guess, 2, 5, 6. So I'm looking at the number in the bottom left down here. Actually moved it down 1 too far. There we go. I can take another animation, so let's just take an idle. Well, these are kind of long. 5, 6, 7, 8, 9, 10, 11, 12. 12 frames. Gee, this one fine. 6. Let's make this bigger. We're not going to bother with like efficiently packing these things in to the sprite sheet. It's going to do it in the most super convenient way for us. And in fact, I want to make sure they're all like perfectly aligned, so I'm gonna get rid of this actually and then replace them. Oh, Ita, how's it going, dude? Welcome to the stream. So what we're doing today is Lunar Lander. Did you ever play Lunar Lander back in the day? Or one of the many clones and versions of it? It looks like this right now. So we're at a point where we have our little engineer guy and he can fly around and thrust. Okay, did you see those SpaceX videos where they kind of have the rocket which like takes off and then just like lands back on some like floating platform and stuff like that? That's kind of the deal, right? Like a physicsy game where you blast around and then there's like gravity and stuff. Club Penguin only kid. Well, do you remember Neopets? Was that before your time? They had a lander clone. That was a whole deal. But the idea is, yeah, it's kind of like a bit hard to control and a bit erratic, and you want to like get it back on these flat landing pads without smashing it to pieces, basically. So kind of like Kerbal Space Program, if you ever played something like that. So you'd have to hit the ground like just like super slowly and like without the wrong kind of direction. Yeah, like yeah, I'm with you on that. Also, big news, Yuta, we hit our Twitch affiliate status, so we now have like channel points and all of that kind of cool stuff going on. Thanks in no small part to your help and contribution, so thank you for that. You did see indeed. Cool. Yeah, if you have any ideas as well for I don't know if I dare mention, you're not the person to mention this to. If you have any ideas for like point rewards and stuff like that, then we will consider them. I use the word consider very carefully because there are no guarantees that we will implement them, but we will consider them. Yeah, so we got this thing flying around, and what I want to work out now is actually have it land and sort of transition a bit more elegantly between like being on the ground and turning his jets on and flying around and stuff. And right now he can just fly straight through the ground, so yeah. Cool. So what I'm doing right now is I'm just pulling some animations out from this sprite that we want to use. So he's got an idle animation where he's just sat on the ground. There's one here where he actually takes off. Yeah, I mean, we don't have it like emotes or anything set up yet, so we don't really have any like sub rewards or anything right now. Yeah, it's good. I thought it would take longer, right? Like I didn't know if it would immediately happen, but you know, we ticked over to 50 followers during a stream, and then immediately after we got all the notifications and stuff like that. Yeah, like yeah, maybe we can chat about some of the other stuff that should be set up for this. Okay, so we've got the on the ground animation, we've got the little takeoff animation, we've got the. I also want to take the loop of him levitating. It's kind of the next stage, if you like. What is this? Okay. Just looking at your emote there, I don't know. I'm not super familiar with like Twitch emotes as well. I'm not one emote for 100 points. Yeah, like 100 points is not a lot though, right? You get that in like 5 minutes or something. Oh, he's actually got landing as well. I kind of need that one. Okay, yeah. That's how it works, right? If you're sub to anyone, you can use the emotes in anyone else's chat. I mean, we're probably going to port over the emotes we have for all the Steam Hands characters, and whoa, okay. It's a lot of stuff. You know what? The death animation for this guy is super long, so I'm maybe not gonna. So I'm probably not gonna integrate this whole thing. It's like 40 frames long or something. This is an awesome animation, but it's a bit crazy for it right now. Also, it will look weird if he's like on the edge of a cliff face when it happens. It won't like line up properly. Okay, so there's our sprite sheet. I'm gonna kind of move this all so that it's more centralized. Okay, let's export that. Right, and now we need to kind of wire up these animations into this bit of code here. So the full animation is now no longer, it's now the third thing down, so it actually starts at 256 or 128 times 2. Maybe that's a nicer way to do that. Let's take idle, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 frames long. Also loop starts at 0. We now have takeoff. Which is does not loop. Poggers, right? Yeah, I'm like I know enough to know about like poggers. That's about the limit of my Twitch culture knowledge. So we have flying, we then also have landing. Which is 4 frames long. Okay, I think that does what we need. Yeah, do you wanna do you wanna try again? Okay, so we naturally have more of a complex transition, right, from being on the ground to flying, because we actually want to let this takeoff animation play. Let's add another state. Takeoff. Yeah, I may do. I mean, I don't think we'll have any trouble like getting it working. Like we have all of our stuff in the Discord, we'll probably port the same things over. So then when we're in this takeoff state, we kind of want to do something like this. we can say, for example, so how long should this take? So if this is like 5 frames, and it's 20 frames a second, so it's like a quarter of a second. This is kind of a hacky way to do this. I should be looking at animations or checking animations are complete and stuff. You know what, let's give myself a function here for is the current animation complete, which is the case if the amount of time is greater than cool. So now I can just say if that's the case, this is when I want to actually you know what, let's actually have them hold up for that whole animation, otherwise reset to idle. That feels like it makes sense. Yeah, I don't know whose dogs these are, but they're kind of cute. So otherwise, if they let go of the up key, then we're going to transition back to idle. Grounded, rather. Okay, I think this set of transitions should work for us. So we are idle, that looks good. We're not touching the ground, which is not ideal. Okay, let's tweak the positioning so that he sits exactly where it needs to be. How far off are we? Like 6 pixels maybe. So let's move everything down by 6. Re-export that. Nice, I think I'm going to turn off our little red circle for now. So there is our guy, happily sitting around. If I press up, he takes off. I can steer the guy. He flies off into the sunset. Hopefully comes back down again. Where is he? There he is. Ah! And it's the struggle to like move him and land him on this platform without splatting him. You often also have like a fuel meter in this game. Okay. Awesome, so I think that's not bad for a first part of this. Next part we're going to work out how to actually have him smash himself to pieces on the ground or like calmly land. And also, you know, we'll tweak the controls and the gravity and the responsiveness and stuff as well. But this feels like Lander already, I feel like. Okay, cool. I will be right back in a few minutes for the next part.